My name is Thomas Moyer. I'm the sales manager for Media Cybernetics. And I'm going to present on our platform, Image Pro software. But before I start, I just want to tell you a little bit about Image Pro. So we have a modular and flexible software platform that brings together everything that you need to perform a cutting-edge image analysis through processing the analysis and then exporting that data. And this is for microscope-based research and quality inspection. So these steps represent the typical image analysis workflow. As Nick mentioned, we do have a Hitachi connector, so you can seamlessly import images from your Hitachi system. We also offer many tools for processing, as well as filtering. The next step would be identifying the areas of interest or objects within your image, and that would be the segmentation step. As an option, you may want to classify those objects, and ultimately you want to extract data from those images. So Image Pro provides tools for each and every one of these steps. So what's new? Well, I'm happy to announce our recent software launch, Image Pro AI. This latest version brings in AI deep learning segmentation for a higher accuracy, and also the ability to count objects and find areas that we previously could not find. With Image Pro AI, we've not only integrated AI deep learning technology for the segmentation, but also application-specific protocols that provide a guided workflow for different types of analysis. So I'd like to start with AI deep learning using convolutional neural networks and how we've implemented that into our Image Pro AI platform. But before I start, I know that artificial intelligence is something that everybody has probably heard of. But I just want to give a very quick recap about what is AI deep learning. So at a high level, we have artificial intelligence. And these are techniques that enable computers to mimic human intelligence using logic, if-then rules, and decision trees. A subset of AI is machine learning. This is a segmentation technique that we have already implemented into the Image Pro platform. And that subset includes more complex statistical techniques that enable machines to improve tasks with experience. And then we have deep learning, a much more intelligent subset of machine learning that enables software to self-learn from data through complex multi-layered neural networks. So I'm going to give two descriptions. The first one is, what is a deep learning model? So a deep learning model is a computational structure that processes data through multiple layers of interconnected nodes to discover patterns and make decisions intelligently, learning from large data sets without explicit programmed instructions. This represents the different layers in the process. First, we have that input layer. We import our image with labels to let the model know what we're trying to identify. That goes through a process you can see with these hidden layers, and ultimately we have a model that's able to find complex structures, patterns, and areas. To get to that endpoint of having a model that's able to identify certain areas, we have to train that model. So model training is just the process of optimizing the model's parameters by repeatably processing data and adjusting to minimize errors. And again, a similar graph showing the input, the middle sections, and the output. So now I want to talk about how we've integrated AI deep learning into the Image Pro platform. So collections of pre-trained models, again, some are very specific to find very specific features in images. Some are more general and have been pre-trained on a very wide variety of objects. But we also give you the ability to clone those pre-trained models and then fine tune them using the materials that have already been used to train that pre-trained model. You also have the ability to train a model from scratch. So if you have a very unique image with unique features, and we don't have a pre-trained model that can identify those features, we have a platform that is an easy guided workflow to train a new model from scratch. So just to give a visual representation of the benefits of AI deep learning and how it's able to tackle these more complex analysis, I want to showcase a few images with side-by-side comparisons using machine learning segmentation and AI deep learning segmentation. In this first image, we have a fairly dim sample, although visually I can see these larger circular objects. It's something that's extremely difficult for machine learning to segment correctly. So you can see in this image on the left with machine learning, it has started to identify some of the outlines of the objects. And this image in particular, I have added some pre-filters and things to reduce the noise and make the segmentation a little bit more accurate. But it is a struggle for machine learning. The deep learning output, this was actually used with one of our general object pre-trained models. All we have to do is set an object diameter, an estimated object diameter size, and it has identified the objects in the image. In this image, we are interested in outlining these striation marks. And this is a very unique pattern. This is called a Widmanstätten pattern. So again, using machine learning, you can see that although I have found the patterns, if I start to gate things out based on area or circularity, it's something that I may be able to fine tune this machine learning algorithm, but ultimately it may not be a repeatable process. If I introduce another image that has has some variations, it may not be repeatable. On the right, we have the deep learning. This was used, we have a pre-trained model for Widmanstätten patterns, and it has accurately identified those patterns in the image. Finally, we have a nuclei mitochondria image. And you can see from a distance, they look similar. It's because we have a lot of objects in this image. But if I were to zoom up, one of the struggles with machine learning is splitting objects. So even if we have enough contrast to identify the various areas within the image, identifying what is a single object when it is connected to a grouping of objects can be difficult. So we have used a splitting technique that's present in Image Pro to try our best to distinguish between those different objects. But you can see we have still counted areas that we're not interested in, and we have not performed splits in particular areas. And on the right, again, this was a model that's included, that's pre-trained. So now I want to talk about deep learning architectures. If you're not familiar, there are several different architectures available for AI deep learning segmentation. So we have decided to implement 3 different architectures into Image Pro. The first is UNet, which is a very good at pixel classification and area identification. The UNet architecture is not as good at segmenting individual objects. We have also implemented StarDist. This is very good at identifying individual objects. It also gives you the ability to count overlapping objects. And finally, we have a cell pose model. And the cell pose model or architecture is used in a lot of our pre-trained models. This is a very good architecture for distinguishing individual and unique objects, and it does a very good job at splitting those objects. We also give you the ability to import your own models. As long as they have a similar architecture to the UNet, StarDist, or cell pose, you can import models that you may have already. And we've made this decision to include the 3 different architectures. Some software will implement one of these or 2 of these, but this complete collection allows you to perform analysis on just about any image and identifying any feature within those images. Like I mentioned, we do have pre-trained models for life science and materials applications. For life science, you can see up top, I do have some optical images. Again, we work with EM, TEM, SEM, but we also work with optical microscopy as well. So here I have some fluorescent models pre-trained, some label-free for cell identification, a very unique retinal blood vessel model, and then TEM mitochondria and TEM nuclei. For materials, we have 2 different titanium grain models. We have a versatile grains model. This is a model that can be used on a very wide variety of grain structures. Versatile particles model, and again, Widmanstatin patterns. So going back to the typical image analysis workflow, again, we've covered importing images, whether that's from your Hitachi system or with one of the file formats that we support. If you need to do any pre-processing or filtering, that's included in the software. And then we've just covered segmentation, either machine learning or specifically AI deep learning segmentation. So at this point, we have our objects outlined. And if we were to stop here, we would be left with a pretty image with nice outlines. But for most of us, we probably want to extract data from those images. So we have the option to classify objects based on many different measurement types. And ultimately, we want to analyze the images and extract the data. So previous to this next feature, we included tools to get you through each one of these steps. And we had macro language where you could tie everything together and create a seamless workflow. That did require knowledge of our macro language and also a much deeper knowledge of Image Pro. So we have decided to implement application-specific, what we call protocols that are guided workflows for specific applications that tie together each and every one of these processes. So our analysis protocols, they're standardized workflows for image analysis. They provide intuitive guided steps that take you through each of the steps to set up your individual protocol and change certain parameters, including the types of data that you would like to output. AI segmentation can be integrated into each and every one of our protocols. We also have pre-made reports for the different protocols. Once you have gone through an initial protocol and you have set up the parameters, you can now save your own customized protocol. You can take it out of what we call interactive mode, the guided workflow, and now we can perform either a one-click operation to go through all of the steps, or you can batch process on a folder filled with images, all with the click of one button. So now I just want to highlight, again, we have life science specific protocols, nuclei, mitochondria, nuclei and chromatin, and then the combination of nuclei and mitochondria. So some of our protocols include the ability to use a single AI deep learning segmentation model, or we can actually incorporate multiple models into an image. So if you're interested in, say, a parent-child analysis, we can create a model to identify the parent objects, and then a separate model to identify the objects within that parent class. For EM, we have quite a few. So we have 2 fiber protocols, fiber separation to fiber thickness, composite materials, grain size, which is ASTM E112, 2 different titanium grain protocols, 3 different layers protocols, parallel, concentric, and curved. You can do a phase analysis, particle phase, we have a particle size, porosity analysis, and Widman-Staton patterns. So at this point, I'd like to introduce Jeff Knight to give demonstrations on how we utilize AI deep learning segmentation and protocols to come up with a very versatile and repeatable analysis workflow.
So today, I'm going to go through a few demos. They're pre-recorded, and I'll stop here and there and point out the important parts, but this is what everyone's been waiting to see, so we can see it in action. So I'm going to show a few biological and a few materials and industrial type of samples. So we'll do some nuclei, the mitochondria model, and as Simon mentioned, we can actually combine models, run them sequentially. So you can actually do complex imaging problems. And then we'll do some titanium grain, and I'll finish up with EV battery looking at some NMC particles. Okay, there we go. So this is TEM image, and there are two nuclei. As you can see by the shape, one's round, one's sort of triangular, depending on the morphology. And the challenge here is you have dark black areas, a lot of mid-grays that you're trying to segment. And first I'm going to show machine learning, which is a pixel classification technique. And as you can see, drawing it looks good, you can outline it. But shortly, coming up. Okay, so I've identified one of the nuclei using machine learning, and then I'll set a background. And then it'll do its algorithm. And you can see where the problem is. You're starting to pick up the mid-gray and the black pixels. Try and separate the background more. And again, you can gate some of these things out to properly find your objects of interest, in this case, the nuclei, but it's a challenge. And if there's any different variation, shading, it just becomes harder and harder. And so the benefit of deep learning is this. This is the nuclei protocol, complete with a deep learning model. So you can see they're organized by different categories and also EM. And selecting the nuclei protocol, again, this is, to see in full glory here, is really going through a step-by-step. It's very straightforward, very simple. Confirming it. Now this is the interactive mode where you're setting up to go step-by-step confirming you're properly segmenting and identify what you want to measure. This is just a visual guide to set the diameter, and that's one of the most important things that you can do is set the proper diameter to find your objects of interest. And this is a cell pose model. Once we confirm that, we can test out the segmentation before we continue. So you can see how I found it. There are adjustments here I'll point out in another protocol where you can dial this in for your own samples. And simply, again, going through in the interactive mode, it will complete the measurement. And then we include a snapshot for documentation purposes. So when you export this to Excel or put in a report, you have the documentation of how that particular sample was segmented and coming back to it. And then finishing up. Again, there's some options here. You can organize the protocol for your own needs and make your own adjustments, and you can save a version of it, especially if you have a different type of sample that uses this basic protocol, but you have a slightly different sample, then you can save that as its own and then recall that over and over again. Next, we'll do mitochondria. So this is an image you've seen before, but again, going through the same thing. Really, once you understand one protocol or one workflow, you can do any of them. Again, selecting from the cell biology group. Simply loading it. And for deep learning, again, you're going to use a graphics card in NVIDIA, because a lot of this is all done on GPU processing. You can also use a CPU for counting, but during the training, you will need to use a GPU. And again, here we using a pre-trained model to find the nuclei. You have different display adjustments that you can set to your own needs. Again, diameter being critical to find your objects of interest. And I'll pause it right there. So what we've done is organize the protocol to really show the features that you need instead of having to look around trying to find the right settings for what you're trying to measure. In this case, with this type of model, not only do you can set the diameter, but you can adjust it. So if you're not quite finding exactly what you're trying to measure, There are settings there that you can adjust on probability and strictness to dial it in. Think of almost like threshold, but it's not quite. But then you can adjust that to dial it in and set it for your own particular sample to properly identify it. And then again, when you've completed it, then you can save that and use it over and over again. So you can see here, it's just running the deep learning model, verifying that everything's correct. It's just doing an adjustment to see if I can dial it in a little bit better. Again, this is very straightforward and very quick and easy to do. Found them a little bit better. And then continuing on. Again, this is the interactive mode. Once you have a protocol set for your particular sample, you can call it up without going through the interactive mode and just doing one at a time. Or you can do a batch process of pointing to a set of folder or subfolders of images and then do a batch process. Here's just an example, saving a version, and then we'll save it back. Then you can look, we call it a model browser, or I'm sorry, the protocol browser, and then select your protocol. So, what happens when you have a more complex imaging problem? So in this case, now I have nuclei and mitochondria. So how do I measure that? Again, using typical segmentation techniques, this is not going to work well. But one of the things in the structure of how protocols are put together, you can run deep learning models sequentially. So in this case, we'll identify and segment the nuclei and the mitochondria. Oops. Again, it's just that step through and verifying your settings as you go through and making adjustments as needed. Again, verifying segmentation. This is just showing that it's running the deep learning. Once you verify the segmentation, press OK and continue. I really didn't talk too much, but we also include a few other settings that if you need to do clean borders or anything like that, want to count whole intact object cells, you have those choices. So again, it's just exposing the tools that you need. Again, these can be edited and modified for your own needs. And now we're moving on to the mitochondria. Again, now I'm running 2 deep learning models. And then I can report both populations. And we can report the population statistics. And we keep track of a range of parameters from morphological and intensity that you can use to describe your sample. And now in this last step, it will now combine all of the data. Again, this can be exported to Excel, saved as a file, put into a report. And finish, and then you can start again. Moving on to a material sample, this is the titanium alpha phase. Again, we've pre-trained these deep learning models that then can be expanded and extended as needed. So again, it's the same exercise over and over again. Once you learn one, you can actually walk through pretty much any of them. And now select the materials EM category. You can scroll through, find the correct protocol. And loading it. Again, this is just confirming. We can also put regions of interest on here. So if you need to, if you have a calibration bar on your image, you can put an ROI on, so you're excluding that. Again, that's going to put it the same one over and over again unless you change it, which is really nice, especially doing batch processing. And now again, these are all the same, really grain levels and texture, or grade levels and texture between this structure in here. And this is the power of deep learning, that you can avoid all of it. See, if you were trying to gate out these small areas, it's pretty hard to do. So that really highlights what now you can do in solving more applications, solving more analysis problems with a properly trained deep learning model. Electric vehicle battery analysis. So this one's a little more interesting. We want to measure the surface area to find the fill area and then everything else. And the challenge is, especially training the model, is these are all the same materials. Some get closer to the surface and they get brighter, and we want to exclude those. And this was actually a fairly simple exercise training this model. This is just a quick one creating, but in essence, I trained the model, found the areas that I want, and in the training, made sure I only identified the areas that I want to measure or the type of sample I want to measure. Besides anything that's really sitting on that surface, and avoid anything that's just below. And then calculate the fill area versus non-filled area. And that was an example of the ROI around there, so I exclude it. And so now, I'm just going to pause that one more time. So anything that's close, but still below that surface where it's been microtomed or cross-section, so we're ignoring all of that. This one's a little close, judgment call there about that spot, but now you can accurately identify things or identify areas or making calculations that are challenging using normal traditional segmentation methods. And so the next step is how to run a batch process. So right now I'm in the interactive state. So it's literally stepping through, verifying your settings. Taking out the interactive state, now I can select a folder, for example, or if you're doing anything with optical fluorescence, you can actually process the multi-well plate. Here I'm selecting a folder, 4 images, and it'll sequentially process each image and then generate that data. And then with a snapshot included, you can verify that your results are correct. You can review them. If you double click on it, it'll actually show the snapshot. Again, that can all be exported. And we have different data displays, pie charts, graphs, bar charts, heat maps. Tom, I believe you're next.
Thank you, Jeff. And thank you, everyone, for joining us to learn a little bit more about our latest version, ImagePro AI. I hope that we have demonstrated our integration of AI deep learning to tackle complex image analysis and segmentation. Again, we have increased accuracy with AI deep learning models, and I feel that we have implemented this in a very user-friendly way. It's actually very complex to integrate things to have them work in a simplistic way. And then protocols to tie everything together to offer a very streamlined, simple, easy to use analysis process for various applications. I'd like to mention that ImagePro AI, we do have packages available for life science that include our life science pre-trained models as well as the protocols, and the same for materials.
Well, thank you very much for attending today, and see you soon. We'll be back for any questions. Thank you.
Thank you, everybody.